Hello, this is Mr. Huff, and I just want to go over some data analysis for the puzzle cube measurements. Okay, what you have in your notebook is you should have a list of cubes and their measurement from end grain to end grain. Notice that on this column here of numbers, if you want it to all have the same number of decimal places, you're going to use these two buttons here, increase and decrease decimal. So if you click increase, it adds places, and decrease, it will remove places. We need to have 4 decimal places for all measurements here. You already have notes about how to insert descriptive statistics for this data set. The ones we will be using mostly are going to be, and I'll highlight them on this, we're going to be using the mean value. We'll be using the standard deviation. We will be using the range value, and we will consider the max and minimum. What I want you, after you enter these, I want you to calculate 1/6 of the range here, and then we're going to divide that into 7 bins here, starting with the maximum and subtracting this 1/6 every time. You could also do a couple more or a couple less bins. You could go anywhere from 5 to 7 bins, but you'll need to recalculate that range value. The one I showed you earlier was using the 7 bins to get your columns. Then after you have this information, you use this bin range and the data to generate a histogram, and it should look kind of like this. So remember, you can grab the corners and stretch it out a little bit, and you can see kind of the distribution of your data. It's kind of a normal distribution. Something funky is going on right here in this area. I would expect these two to be inverted if it was real. And then this is kind of showing me that I probably have some outliers on the low end. Okay, so what we're going to do now is we're going to add in a scatter plot. So what I'm going to do is choose cube and hit shift control down and right and choose my whole data table. I'm going to insert, and I'm going to point at the one that says insert scatter plot. I'm going to choose the one at the top left. Okay, I need to add the axis titles by choosing this plus, and here's my axis titles. Once I define those axis titles, I need to stretch it out a little bit so that we can continue with what we're doing today. So I'm going to make this kind of blown up a little bit, even though it doesn't really fit on the screen too well. Alright, we need to identify on this scatter plot where the median is, and we're going to go with plus or minus 2 standard deviations, and anything outside of that we probably want to replace. So what we're going to do now is, I'm going to kind of scoot this over so I have some room. I'm going to put, let's see, parenthesis plus 2 standard. Alright, so I'm going to identify those numbers that are plus and minus 2 standard deviations from the mean. The mean is easy, so we will just hit equal and we scroll up here and find mean and click on that. And then here we're going to put equals the mean that we just copied plus parenthesis 2 times, and we scroll up here and find our standard deviation, which is in cell F9 in this table, and then I hit enter. And then here we're going to go equals the mean minus parenthesis 2 times our standard deviation, which is F9, and hit enter. And now I have my values, so I can tell. I'm going to shrink these down a little bit, use fewer decimal places, so I can tell right here anywhere between. So let's go mark them on here. So let's start with the mean. I'm going to choose our table, and I'm going to look up here. It says formats. I'm going to click on that, and you can see right here it has insert shapes. I'm going to choose the arrow. Okay, I find that the easiest way to line an arrow up is to click on one of the grid lines and drag it across, and then line it up exactly on the grid line, and then let go. Now you have an arrow you can drag around, and I'm going to move this to where the mean is. So the mean is 0.7542. Going to grab that. So there's 0.75, 0.755, so 7 or 0.7542. It's going to be about 80% of the way up from there, so about right there. Okay, somewhere in there. And then I'm going to hold down the control button, and see how my cursor has a little plus next to it. I'm going to click on that arrow and drag one up, and then I'm going to do that again, control, and click on that arrow again and drag it down, let it go. Now I have copies of that original arrow. So the upper limit is 0.766. So that's going to be about 20% above 0.765. So somewhere, it's almost 0.77, almost 7, yeah, 0.76. So that would be 65, 66, 67, 68, 69, so somewhere in here. And then the lower limit is 0.7415, so just a little bit over 0.74. So I'm just kind of estimating about where that is, so that's about 0.74. Alright, when I look at this, most of my data points are in between those two lines. So I have all of this data kind of clustered in the middle. I have some questionable ones. This point, cube 23, and this point, cube 13, are really close to that upper limit that we set based on plus or minus 2 standard deviations. And this one down here, cube 11, I definitely want to screen him out. And you can kind of look and see that there are very few that are even close to that. So I'm going from the format tools, gonna add a little arrow here, make myself a note. So we're gonna point at that one and type in remove. So I need to go find cube number 13, take it out, and find one that has a value that is closer to my mean. So 0.754 is what I would like to see. So I need to swap that one out. Some options here: you could trade with someone that may have one that's closer to that value, or you could get one out of the drawer to replace it with. Don't throw anything away. The cube is not bad just because it's not in your data set. It would fit in someone else's data. So once you have all of this together, then save this file and turn it in for me, showing your analysis of your cube measurements.